This is number 4 here. 4 is asking us find the zeros, multiplicity of zeros for the for the given expression. So f of x is equal to 4x to the power of 7 plus 40x to the power of 6 plus 100x to the power of 5. So we first want to find the zeros. So how do you find the zeros? Well, what I want to do is I want to solve for this x value here. So how do we do that? Well, this is to the power of 7, so we can't, there's no specific type of form that we have to use. But what we can do here is we can factor, firstly. And what we can do here is we're basically setting this guy to 0. F of x has to be 0 to find, to solve for our zeros here. So we're going to set this to 0 first. And we can think of it as solving for the x-intercepts or zeros. They're kind of interchangeable terms here. And then what we can do here is we can look at these 3 terms. Do we have a common factor? Yes, we do, right? Common factor here is x. So I can say its common factor is x, but what is the degree of the common factor? Well, I have x to the power of 7, x to the power of 6, and x to the power of 5, which means I can actually take out x to the power of 5 here. So my variable is I would take out x to the power of 5, but I can also take out a number, right? Because as you can see, if you look at the constants here, only the constants, I have 4, 40, and 100, which means the greatest common factor of these guys, all 3 terms, is going to be 4, because 4 divides into all of these guys here. So I'm going to have 4. So I have 4 to x to the power of 5. I can common factor that entire term. And then I'm going to get, let's see what I'm going to get. I'm going to get here x. I'm going to be left here with x squared, because I have x to the power of 7 divided by x to the power of 5, which is x squared, plus, and then I have 40 divided by 4 here, which is going to give me 10. And then x to the power of 6 divided by x to the power of 5, which would just give me x. And then 100 divided by 4 is going to give me 25, right? And the x to the power of 5 and x to the power of 5 canceled out. So now we have, this is an easier expression, right? We have 0 equals 4x to the 5. And then we have this trinomial here. And this trinomial is actually really good. It's an example of a perfect square trinomial. Because I have a 25 value here, which is a square root of 5, and 5 times 2 is equal to 10. So this here is an example of a perfect square trinomial. So if I factor this, this is going to give me x plus 5 squared. So now what we can do is we can actually take both cases here. We can break this down into, this is case 1, and this here is case 2, and we can set it to 0 to find our zeros, right? So for case 1, 4 to the power of x to the 5, 4 times x to the power of 5 is equal to 0. Divide 4 by both sides, I'm going to get x to the power of 5 is equal to 0. And then finally, if I fifth root both sides here, it's going to still equal 0, right? So x to the power of 0 is definitely a factor. And then for this guy here, if I set x plus 5 squared equals 0, what I can do, again, I can square root both sides, so I'd get x plus 5, which equal to 0, and then I can simply subtract 5 for both sides, so we get x would equal negative 5. So my 2 factors here are x to the power of negative 5 and x equals 0. So as you can see, zeros are 0 and negative 5, which is great. So we've solved for these zeros now, and now we have to solve for the multiplicity of these zeros, right? And how do we solve for a multiplicity? Well, we simply look at the we look at our zeros here and see what what is being defined here. So we can say that we set our equation to 0, right? We have 4x to the power of 5 times x plus 5 squared. And we can plug in these zeros back, right? We could say that 4 is, this x value is going to be 0 to the power of 5 times x plus, this here is negative 5 to the power of 2, right? And in order for us to find multiplicity, we simply just look at the degree of these zeros. So in this case here, this is x to the 5 here. So x equals 0 will have multiplicity of its degree, which is simply just 5. So as you look at the 4x to the power 5 term, as we solved in our previous solution here, x equals 0 for this term. So we can say x equals 0 has a multiplicity of 5 here, because this is x to the 5. And x equals negative 5 will have a multiplicity of its own separate degree, which is x to the power 5 to the is x plus 5 is to the power of 2, right? So this here would have a multiplicity of 2, so its own degree. So in this case here, these are our answers, right? So zeros are 0 and negative 5, as we solve here, and the multiplicity of 0 is 5, which is good, and multiplicity of negative 5 is 2, as determined by the degree of those polynomials. So this solution here is correct.